6 to our math lesson. Today we're going to be covering calculating area, and this is a review from what we've learned in class, and we're also going to learn about perimeter and area. Alright, so learning to calculate area in grid lines is an important skill for your exams. So let's see how do we calculate area in grid lines. Now, this rectangle right here has a width of 7 centimeters and a length of 3 centimeters. Now, in order to find area, what we do is we multiply the two sides, which are the width and the length, which means it's 7 times 3, that's 21. Yeah, and don't forget the measurement units, because without the measurement units, as we explained before, it's useless and it's meaningless. Like, though the number that you write doesn't have a meaning. So when you write centimeters squared, that means you're referring to area, and that's how you get the full mark, really. All right. So one more thing. You see that our multiplication result was 21 centimeters squared. But if we look at the grid lines and we counted how many squares is actually covered by that rectangle right there, it's 3 right here, okay, and that's 3 right here, that's 6, another 3, that's 9, another 3, that's 12, another 3, that's 15, another 3, that's 18, another 3, that's 21. So this should give you an idea that calculating area is actually calculating the surface of something. Like, the surface of this rectangle is this many centimeters squared. Now, saying centimeters squared is basically each of these squares. We're imagining it as 1 by 1, so 1 centimeter by 1 centimeter. So when we say 1 centimeter squared, that means we're talking about one of these small squares. So 1 small square, 2 small squares, 3. Instead of saying square, we write centimeter to the power of 2, or centimeter squared. Now let's see which is the area for this one. If we would calculate each square, we would get 20 squares we have, and the answer is side times side, which is 5 centimeters times 4 centimeters equals to 20 centimeters squared. Now, same thing here. We're covering this many squares, and they're 9 like this, 9 centimeters, and it's 1 centimeter like this. That means 9 times 1 equals 9 centimeters squared. Okay, so on this one is 4 and this one is 2. By the way, we also refer to these square rectangles as 4 by 2. When we say 4 by 2, that means 4 times 2, so that's 8 centimeters squared. Don't forget, this is very, very important that you write the centimeter squared. One last one, and we're gonna move on to the perimeter. 6 centimeters squared by 6 centimeters by 2 centimeters, multiply them, it will be 12 centimeters squared, right? So this is it for area. Now you can calculate the area of anything, including irregular shapes, meaning if you have this obviously a regular shape on this grid line, if you have an irregular shape right here, what you do to calculate its area is that you're gonna count how many squares is that shape is covering, really. Even if it's like irregularly, you can estimate the amount of squares the shape is covering. For example, such as the sun. You see this, it's not a rectangle, it's not nothing, right? Now we have many shapes, such as these, we can calculate the area for this one, right? We can estimate the area for this one. It would be it's 1 square here, 2, 3, and then 4, but then this last one doesn't have this side, right? So let's see. It's a puzzle, right? It's like a jigsaw, right? So if I calculate this part right here of this square and a little bit of here, and I put it here, that will be 4 complete squares. That means the area is more than 4 centimeters squared, including all of these. This could be like 1, and a bit of over here would be, a complete square. If we take this bit over here and we put it right here, and that's 5 centimeters squared, and I'll calculate this and this and this as 1 as well, so around 6 centimeters squared, and I would still have a little bit here, right? So you can estimate it's around 7 centimeters squared. Now you can estimate it, since this shape really doesn't give us any it's not very clear. You can't really calculate each square very precisely, but if we have some shape like this, right, so we can get out a full rectangle right here. We would estimate the area for this, and then the area would be this big rectangle inside plus all the bits, and we estimate how many squares do those bits collectively form, and we would estimate the area. But if you have regular shapes such as these, even if you have them in different like combinations, like for example we have let's see right here, we have regular shapes such as these. So we call them compound shapes. If you take a look at these, they're very simple to understand if you understand how area works. Now you see this one is a square, this one is a rectangle. Now in order to calculate the area for this compound shape, you would first calculate the area for this square, and then calculate the area for this rectangle. And then in total you would put the both areas together, you would get the total area of this compound shape. Now this is why it has been sectioned into area 1 and area 2. You can find area 1 being 4 centimeters squared. Area B, or area 2, would be 2 times 5, 10 centimeters squared. Collectively, this one is 4 centimeters squared, this one is 10 centimeters squared. The answer would be 14 centimeters squared. Same thing right here. All of these examples, by the way, this is a homework, so you will be solving the rest, 2 until 6. Or we have such as these shapes, right? So in an exam you would get something like this. It's not really sectioned for you, you can section it yourself. You can see that this part of this compound shape, if I draw a line right here to right here, I would get a small rectangle and then a very big rectangle next to it. So the rectangle that's small would be 3 by 3. That would be 9 centimeters squared, and the big one would be 8 by 6, and that would be the it would be 8 times 6, which is 48 centimeters squared, and then plus 9. Okay, that would be, I think, 57 centimeters squared. So 48 plus, I'm doing it on my calculator just to make sure, is 57 centimeters squared. Yes. So you can do the rest such as this, or sometimes you can figure out what side is what's the side of this what's the measurement for this side? Sorry. So if you have something like this, and it doesn't have any measurement right here, but you look at the corresponding line, you look at this line, and it says from right here to right here, it's 3 centimeters. So you know that also this line, because it's like opposite and parallel to it, it's from right here to right here is 3. And then on this side, it says from right here until right here is 4, right? So this is a 3 from here to here, and it's 4 from here to here, then the whole thing is 7 centimeters, right? So you can like find the length of the sides, such as these. Okay, now calculating perimeter, the reason why we are recovering this is that I want you to make a difference between what is perimeter and what is area. Now I know all of you know it and we have had it, but it's important to not to mix those two topics. Now area was us calculating each grid, like counting each square. So we will, like, if I would calculate the area for this rectangle, I would say 1, 2, 3, 4, 5, 6, and I would count it all, and I would say, okay, or I would multiply side by side, and I would say, okay, that's the area. But the perimeter of this rectangle is basically the measure for the side of each, for each side. So each side of this rectangle, we're gonna add them together. So it's like saying the length of this side plus the length of this side plus the length of this side plus the length of this side. So we're not actually calculating the squares inside, we're calculating the length of this side of this square. It's 1, 2, and 3. That's 3 centimeters. Okay, and right here it's 1, 2, 3, 4, 5, 6, 7. Only this side of the squares, right? It's 7 sections or 7 centimeters. Now if we calculate each of them, like if we add each, right? So it's going to be 7 plus 7, that's 14. And 14 plus 3, 17. 17 plus 3, that's 20. And we say 20 centimeters. This means we're referring to length, not area. Okay? What about this one? It's basically, it's 6 centimeters, 5, 6, 5. And we are calculating them all. It would be 22 centimeters. Okay, let's do this one. Perimeter, it would be this, plus this, plus this, plus this. It would be 20 meters. What about this one? 8, 4, 8, 4. And the answer is 24 meters. So you can get an idea like of what the perimeter and area was. Now you can see right here, right? The difference is quite obvious. Now another thing to review is multiplication grids. Now let's go through multiplication grids one by one. Alright, let's do number 1. Multiplication grid is basically there for us to simplify the process of multiplying. For example, we have two numbers such as 13 and 9. We're trying to multiply them, but we don't know really the answer because 13 is not in the multiplication table for 9. 12 is, but 13 is not. So what we're going to do is that we draw a grid like this, such as this we have. Yeah. So we're gonna say, okay, so one of the numbers is only has 1 digits, which is 9, right? So we're just gonna add, write 9 here, which is in one grid. And then we have 13. We're gonna separate the 13 because 13 is basically 10 plus 3. So we're gonna write 10 here and 3 here. So we're gonna separate the 13 into 2 smaller or easier to multiply numbers. Now we're gonna once multiply the 10 with the 9 equals 90, And then we're going to multiply 3 with 9, which equals 27. Now, in order to answer the original question, which was 13 times 9, we're going to add these two together. So 90 plus 27, it's 117. Now, if you would have a calculator and you would multiply 9 with 13, you would also get 117. Now, this is a homework. You can do it the same way. Another more complete